when you think of the word diamond, you probably picture jewelry, right? A ring, a necklace. Well, today we're going to ask you to forget all of that. We're talking about a massive shift where the diamond is being recast from the queen of gems to the new queen of industries. Let's get into it. So it all starts with this one big question. Why are the United States and Japan suddenly teaming up to build a massive synthetic diamond factory? It's a move that's making some serious waves in the tech world. What is going on here? Why are two of the planet's biggest economies all of a sudden obsessed with manufacturing diamonds? Okay, so let's break down this deal. And the first thing you have to understand, to be crystal clear, is this has absolutely nothing to do with luxury or sparkle or anything you'd find in a jewelry store. This is about something way, way more critical. We are talking about a project that is just one piece of a jaw-dropping $550 billion investment package between Japan and the US. Now, whenever you see a number that big, you know this is not just some corporate partnership. Now, this is a major strategic play with huge geopolitical stakes. And this really is the heart of the matter. This whole investment is basically a giant blinking sign that diamonds have officially become a critical strategic asset. The race to dominate the future of AI and next-gen semiconductors, yeah, it's not just about silicon anymore. It's about diamonds. So, to really get why this is such a revolutionary moment, we kind of have to look back at the old guard, the world of the gritty industrial diamond. It's a market that, for a long time now, has been run by one major player using one specific type of technology. I mean, just look at this chart. The imbalance here is absolutely wild. China controls roughly 85% of the entire global supply of industrial diamonds. That's not just being the market leader, that is a near total monopoly. And it gives them incredible leverage over tons of industries. So how do they do it? Mostly through a method called HPHT. That stands for high pressure, high temperature. You can basically think of it as a brute force approach. You're just recreating the insane conditions deep inside the earth to turn carbon into diamond, and you're doing it fast and cheap. And this HPHT method, it's perfect for churning out massive quantities. China built these huge industrial clusters that just pump out tons and tons of diamond powder and tiny little crystals. This is the stuff that goes into saw blades, drill bits, and grinders. It's a volume game, you know? It's not really a high-tech one. Okay, but this is where the plot twist comes in. A totally new technology has emerged, and it's creating a whole new class of tech-grade diamond. And this stuff isn't for cutting through concrete, it's for building the future of electronics. Let's just compare the two for a second. You've got HPHT, which is all brute force, right? It makes abrasive grits for tools. But then you have this new method, CVD, chemical vapor deposition. This is all about finesse. It patiently grows these perfect, ultra-pure layers of diamond, one atom at a time, onto a surface to create flawless wafers for high-end electronics. It's really the difference between making a pile of gravel and growing a perfect crystal. So why is this tech-grade diamond such a game changer? Well, it boils down to one of its physical properties, thermal conductivity. Simply put, diamond can move heat 5 times better than copper. In the world of high-performance electronics, that's not just an advantage, it's an absolute superpower. And here's why that matters so much. Today's AI chips and data servers generate an insane amount of heat. So much, in fact, that they risk literally melting or having to slow down to protect themselves. Diamond wafers act as the ultimate heat spreader, just pulling all that damaging heat away, which lets these chips run way faster and more reliably than ever before. And the potential applications here are just mind-blowing. We're talking about everything from ridiculously fast semiconductors and 6G networks to quantum computers, and even devices for space exploration that have to survive in a total vacuum with intense radiation. This one material could unlock a whole new frontier of technology. Now, you can bet a technological leap this big did not go unnoticed. It has officially kicked off a new global diamond race, and it is playing out like a high-stakes chess match between global powers. And here's what really lit the fuse. China, seeing the incredible potential of these tech-grade diamonds, moved to protect its dominance. It started slapping export controls on synthetic diamonds, officially labeling them a strategic material. That was a clear signal to the rest of the world. Diamonds are now an instrument of national power. This timeline really lays out how we got to this point. In the past, China built up its 85% market share with that older HPHT tech.
In the present, it's using that power to control the supply. So for the future, the US and Japan are forced to respond by building their own trusted supply chain. The inevitable outcome? A global market that's split right down the middle. And this is pretty much what that future looks like. On one side, you'll have a China-led bloc focused on cheap, high-volume HPHT diamonds for traditional stuff like tools, and on the other, you'll have a US-Japan-EU alliance focused on these ultra-pure CVD diamonds for strategic things like AI, defense, and space. It's like two parallel diamond universes, both competing for the future.
In this new high-tech race, you've got your current leaders, companies like the UK's Element 6, which is actually owned by De Beers, and Japan's Sumitomo Electric. But at the same time, you have other tech powerhouses like South Korea that are suddenly realizing they're about 5 years behind and are now scrambling like crazy to close that gap. The race is definitely on.
So, what does this all mean? Where is this all headed? Well, we are truly watching the dawn of a new industrial era, one where our most advanced, most powerful technologies are literally going to be forged in diamond. And you can bet there's a ton of money on the table here. Even though it's still a small niche, this diamond for semiconductors market is projected to grow at a compound rate of over 20% a year. This isn't just some small trend. It's on a path to become a multi-billion-dollar cornerstone of the entire semiconductor industry.
There's a quote that just perfectly captures this whole transformation. The material that we have valued for centuries because of its beauty is now being valued for its incredible, unmatched industrial power. The Queen of Gems is truly being recast as the Queen of Industries.
All of which leaves us with one last big question to think about. For decades, all of our technological progress has been built on a foundation of silicon, but we are now pushing up against the absolute physical limits of what silicon can handle, especially with heat and power. So you have to ask, is the age of diamond just getting started?